We've relied for years on traditional VPN solutions that worked great in the times before COVID and work from home. Times are changing though, and for those of us responsible for managing secure remote access to corporate resources, there are better, more secure, and more efficient ways to give your users access to the resources they need. In this video, we're going to take a look at Twingate's next generation secure remote access product as a replacement for your legacy VPN. Let's get to it. Hey there, HomeLabbers, self-hosters, IT pros, and engineers. Rich here. Traditional VPN, as we know it, is a dinosaur of the past. How a company's users access information and from where has changed, and if you're like me, you're looking for solutions to improve user experience, increase security and visibility, and be able to adapt to the changing corporate landscape with resources in the cloud and on-premise. In this video, I'm going to dig into Twingate and its novel ZTNA approach to secure remote access. Full disclosure, this video is sponsored by Twingate, so with that, let's start with some background on Twingate and an overview of ZTNA first.
Twingate is a technology company that specializes in zero trust network access, providing a VPN alternative with a focus on secure, efficient, and reliable network connections. It aims to simplify security by enabling secure access to corporate resources without the need for traditional VPNs, promoting ease of use, scalability, and robust security. The company's platform integrates with various identity providers and offers granular access control, peer-to-peer connections, and detailed network analytics. Established in 2019, Twingate developed a solution to secure remote access, addressing issues arising from outdated VPN technology. It provides a modern approach to ZTNA, making remote access more secure, usable, and reliable. The company's philosophy centers on providing enterprise-grade services with consumer-grade usability. It has a core team in Redwood City, California, but operates as a remote-first organization with a global presence.
Alright, now let's talk about ZTNA, or Zero Trust Network Access, and what it actually means.
Zero Trust Network Access, or ZTNA, is a security model and set of technologies that enforces strict identity verification for every individual and device trying to access resources on a private network, regardless of whether they're inside or outside the network perimeter. Unlike traditional security models that trust devices within the network perimeter, ZTNA operates on the principle of never trust, always verify. This means that access to the network and its resources is based on a strict verification process and not on the location of the user or device. Some key aspects of ZTNA include strict identity verification. Every user and device must authenticate and be authorized before gaining access to network resources. Least privilege access. Users and devices are given a minimum level of access necessary to perform their functions. Micro-segmentation. The network is divided into small, secure zones to limit user and device access to specific areas. Continuous monitoring. The network continually monitors and adjusts access permissions based on changing context and threats. ZTNA is part of a broader security strategy known as Zero Trust, which emphasizes security in an environment where traditional boundaries, like the network perimeter, are no longer as relevant due to cloud computing, mobile devices, and remote work.
To sum up in my own words, in systems that utilize a ZTNA security model by default, all users are untrusted regardless of their location. For example, if you're using a traditional VPN solution that exists on the edge of your network, once your users are authenticated and inside the walls of your network, they're assumed to be no longer a risk, and therefore there are no restrictions on where they can go and what they can access. In a ZTNA security model, all users and devices are assumed to be risky by default, regardless of location, and therefore need to prove who they are when they attempt to access resources. So, with that out of the way, let's take a quick moment and go over Twingate's overall architecture and how it can help you solve your remote access needs.
This is Twingate's architecture overview diagram from their documentation. Twingate is a security solution designed to ensure secure network access without requiring knowledge of the underlying network configurations. It uses four main components: the controller, client, connector, and relay. The controller manages access and configurations, while the client, installed on user devices, handles authentication and establishes secure connections to resources. The connector works within private networks to manage and authenticate connections, and the relay facilitates communication between clients and connectors, ensuring secure and efficient data transmission. Twingate provides complete documentation on their entire authentication process, and it's definitely worth reading through.
Alright, let's examine how Twingate fits into the ZTNA security model and what makes it a next-generation replacement for your aging VPN infrastructure. I think the best way to do this is to go through the setup process, so let's get to it.
If you haven't already, the first step is to create an account. Twingate offers accounts for up to 5 users and 10 networks, or you can start one of their 14-day trials for their business plans, which features even more functionality. Once you've created an account and created your tenant, you'll land on the overview page. Our first task here is to create a remote network. Since we don't have any defined yet, we'll click the Add Remote Network button on the left to get started. Out of the box, Twingate supports a variety of cloud providers and also on-premise deployments as well. We're interested in replacing our traditional VPN, so we'll be deploying on-premise. We'll give our new remote network a name, 2GT Network, and we'll click Add Remote Network. Perfect. Let's swing up to Remote Networks at the top and continue our deployment. This is the Remote Networks tab, which is where you'll see any and all remote networks you've deployed and can configure them in the future. We see our freshly created network below, so we'll click on it. If you remember from earlier, connectors need to be deployed within your network to facilitate access to resources for remote clients. Twingate generates 2 unconfigured connectors for each network deployed, and they're given random names by default. Twingate provisions 2 by default for redundancy and load balancing. If your company has a lot of remote clients, deploying more connectors will spread out the load and help balance out your user demand. We need to deploy a connector into our network, so to start that process, we'll head over and click the Deploy Connector button on the right. Connectors can be deployed on a variety of different platforms, and Twingate really has worked hard to make deployment as easy as possible for whatever your environment looks like. We'll be deploying our first connector on an Ubuntu Linux VM in my network, so we'll select Linux. Our next step is to generate tokens to secure the communications between the connector we're deploying and the controller. To do this, we'll click Generate Tokens. For security purposes, Twingate requires you to authenticate to generate tokens, so we'll click the Authenticate button to authenticate. Since our SSO is through Google, I'm prompted to pass through Google SSO. Alright, tokens generated, we'll scroll down and grab the single line command that Twingate built for our deployment. If local logging is important to you and your security team, you can click the radio button to enable local logging for the connector. Down in step 4, we see the single line command Twingate built for our connector deployment automatically. Let's do a quick deploy. We'll click Copy Command, and then I'll pop over to an SSH connection I have to my Linux VM, paste in the command, and hit Enter to kick off the installation. The installation will automatically pull down the necessary packages for your Linux distro and deploy the connector. And as you saw in the browser behind the SSH console, the connector is already called home. Let's take a look at it now. The last thing I want to do here is change the name of the connector to align with the system it's deployed on. So I'll click Edit and rename it to something more recognizable. Perfect. All done. Let's head back over to the Connectors tab.
Just a quick note about tokens and keeping them secret. Always keep your tokens secured. Twingate doesn't allow you to reuse tokens once they've been paired with the connector, making them essentially a one-time use item, but in general, don't share tokens with anyone.
In the Connector tab, we see our newly deployed Healthy Connector. The Connector tab is where you'll see all deployed connectors in your organization. Let's head back over to the Remote Networks tab and see what the status of our remote network is. The 2GT network is now yellow because we only have a single connector deployed, and clicking on it shows us the healthy connector and one not yet deployed. For the sake of moving on here, we'll continue with a single connector. Just know that in your setup, you should deploy at least 2. Our next step is to add a resource to access from within the 2GT network. To do this, we'll click Create Resource. Resources are exactly what they imply. These are systems or services within your network that your deployed connector can reach. Twingate accepts both IP addresses and CIDR blocks as well as DNS hostnames to access a resource. I want to provide access to my TrueNAS Scale host inside my network. So I'll first provide a label to describe the asset, call it TrueNAS Scale, and then in the address field, I'll type in its internal DNS hostname of supersan.tracelink.home, and then I'll click Create Resource. Next, I need to select the group of users who will be allowed to access the resource. I currently only have the default group defined named Everyone that includes all of us here at 2GT, so I'll select that group and then click Grant Access. And just like that, as long as the Twingate client is connected on my devices, I'll be able to access that host by its internal DNS hostname from anywhere. Now, just for contrast, let's say you wanted to make a specific IP address or even an entire internal Class C range available to your remote clients. Easy, we'll head back up to Create Resource, enter in a label for the resource. In this case, I'll make my ServerNet subnet available, so I'll type in ServerNet, and then down in the address field, I'll enter in the entire private Class C I'm using for my server network in CIDR format, and click Create Resource. Again, I'll select the Everyone group so that the guys can access these IPs as well, and click Grant Access. And just like that, now anytime someone attempts to connect to an IP address within that resource while connected anywhere using the Twingate client, they'll be able to access it.
This is a perfect example of zero trust network access. By default, a user has no access to resources without that access being explicitly defined for them, and you can create any number of different groups to assign those resources to. Using different groups and group memberships allows you to have granular control over the different resources without having to manually define that access for each individual user. This allows you to provide least privilege access at the network level instead of just at the service level, meaning a user won't even be able to attempt to access a resource in the first place. Twingate also provides a lot of configurability and control over what devices your users can use and how secure they are. Let's take a look at that now.
In the Devices tab, you can see a full list of all the user devices that have connected to your Twingate tenant. You can see in this list here that I have my Twingate client installed on my MacBook Pro and my iPhone. Clicking on any of these clients will show you information about the make and model, OS version, and more. Back to Devices and heading over to the Security sub-tab, we can build trust profiles and define minimum OS requirements to help create standard minimum requirements for your remote devices. This is commonly known as device posture, and it's how you keep users with risky hardware from connecting to the resources in the network. For example, I can quickly and easily make configuration changes like requiring the client to have hard disk encryption enabled and an activated firewall for macOS, establishing a minimum level of security for connecting clients. I can also block entire classes of operating systems from accessing my network. Lastly, Twingate also features the ability to create policies that affect the resources assigned to them. Policies allow you to apply extra security to more sensitive resources on your network. Policies also govern the authentication requirements for your clients, like how often they need to authenticate and any MFA or two-factor requirements you want to apply to your users. I have the default policy shown here, and if we click into it, we can see that the default policy allows any device as long as it meets the standard device security requirements to access the resources it's assigned to. Policies can also affect authentication requirements and how frequently a client is required to authenticate against your identity provider, giving you granular control over client validation and authentication.
One of the big things I appreciate about Twingate is the sheer amount of documentation they have publicly available for their product. Not just setup guides and how-tos, but also information into the architecture and design, stuff that is extremely important to people like me who need to make an informed decision on the security of a product like this. Twingate also publishes its GDPR, HIPAA, and PCI DSS compliances, and has a SOC 2 report available on request. I also really appreciate that Twingate makes this available for free so you can take advantage of their enhanced security and remote access in your home lab and home network as well. So now it's your turn to check out Twingate. Head over to their website at twingate.com, sign up for their free starter plan that gives you 5 free users and 10 networks for free, or sign up for their free 14-day business trial, kick your traditional VPN to the curb, and take your remote access into the future with ZTNA and Twingate. Thanks for watching.